Hello guys and welcome back to LeetLogics. This is the append characters to string to make subsequence problem from LeetCode, and the number for this is 2486. So in this given problem we are given with two strings S and T consisting of only English lowercase letters. So what we have to do in this is that we have to return the minimum number of characters that needed to be appended at the end of S string so that the T string becomes a subsequence of S. So a subsequence is a string that can be derived from another string by deleting some or no characters without changing the order of the characters. So a subsequence, let me tell you what a subsequence. So suppose we have a string. So you can take the characters from the string and make a new string, uh, and this string will be subsequence if the characters what you have taken, their relative order of position remain the same as in the parent string. So then only it is a subsequence. So relative order of the characters is very important in this. So the intuition for this is to make T a subsequence of S, we need to find the longest prefix of S that is already present in the T string. Sorry, we have to find the longest prefix of the T that is already present in S, and then the remaining characters the remaining characters of T will that will be not a part of S, we will append those characters. So in this way we are going to solve this problem. So for this we can use a two pointer approach, and then using the two pointers to get the index, and then we can count the number of remaining characters, and that will make the process easy for us. So how we are going to do this, like we will be keeping a pointer for the S, we are going to keep another pointer at T, and then we are going to traverse and match. If both have same indexes, then we can increase the count, otherwise we can simply uh, pass the iteration. So let's see through an example. Suppose we have the same example, coaching and the coding one. So like uh, we have a we'll declare a variable S index starting which start as 0 for string S, T index for T, and then we have the length of the strings as well. So we'll start the traversing. So for S index, for the first index, when S index and T index is 0, both the characters are C, that is true, so we can increment S and T. Now for the second character, that is O, so the second character in both the string is again O, so we can again increment the counter. Yes. Now we come to the third character. Now the third character in the S is A because of it is coaching, and in the T it is D because of the coding. So in this case we are only going to increase the counter of the S and not going to increase the counter of the T. So you can see here 3 becomes the S index becomes 3 and T index is still 2, which was the same in the last iteration as well. Now we'll again match if anything matches. So you can see C doesn't match with D, okay, increase the S. H doesn't match with D, increase the S. I doesn't match with D, increase the S. N doesn't match with D, increase. G doesn't match with D, and gradually we'll reach the end of S. Now when we reach the end of S, we have seen that we have two characters which are already of T which are already present in T, and the length of T is actually 6. So what we can do is that we can simply return 6 minus 2, and that will be our answer. And you can see 6 minus 2 is also our answer. So uh, we are going to count the remaining characters, like we have already CO in the substring. Now we are going to count the DI, we are going to add the DING to the coaching, and we will simply have the subsequence in the string S. So this is how we are going to solve the problem. Now let's start with the coding part, then afterwards we'll come to the complexity part as well. So first of all, we'll have an S index that will be 0, and a t index that will also be 0. Then we have a s length equal to s dot length, and a t length it is a variable. So now we are going to simply match the s index character with the I index character, but we have to make sure the s remains less than the length, because we have to keep it in the bounds, and t index remains within the t bounds. Okay, and in this we can simply check if s dot char at s index equal to t dot index, sorry, this will be t dot char at t index. So if both the characters match, what we were doing? We were doing the t index plus plus and the s index plus plus as well. So we can write the s index plus plus, but we have to, if this doesn't match, then also we have to increase. So we'll write it outside the loop, and at the end of the while loop we can simply return the t length minus the t index. So let's try to run it. There's been some error, so sorry for this. So this thing runs fine. Let's try to submit it. Okay, you can see completed with a good time complexity and a good memory complexity. So if I tell you the time complexity, so the time complexity for this solution will be O of the n plus m, but actually it is O of length of string s. But I've seen this in interviews, like we have to say it is the sum of s and t, but if you say it is the O of length of s, it is also fine. And the space complexity is O of 1, because we are only using some variables to store the index and the size. So you can also check the C++, Java, Python and the JavaScript solution by going to the solutions panel and check this solution. This is my solution. You can see the intuition, the approach, the complexity, the example explanation, the tables, explanation table, the Java code, C++ code, Python code, JavaScript code. And yes, do remember to upvote me. So I hope you understood the logic, and make sure you like the video and subscribe to the channel. So thank you for watching the video. Have a nice day.